Welcome to the Explainer. Today, we're becoming code breakers, but instead of secret messages, we're going to be decoding the language of number patterns, all by using arithmetic sequences.
So let's just jump right in with a puzzle. Imagine you start a new workout plan. Day 1 is 10 minutes. Day 2, 12 minutes. Day 3, 14. You get the picture. You add 2 minutes every single day. The question is, how many total minutes will you have worked out in a 30-day month? Now, you could sit there and add up 30 different numbers, but honestly, who wants to do that? By the end of this, you'll be able to solve this in just a few seconds.
Here's our game plan for cracking the code. We'll start by decoding the patterns themselves, then we'll get into the secret formula. After that, we'll cover how to sum it all up, the algebra behind it, and finish with some really helpful shortcuts. Okay, let's dive into this.
First things first, we need to learn how to actually spot the patterns we're looking for.
So, take a look at these lists of numbers. In the first one, 2, 4, 6, 8, well, we're just adding 2 each time. The second one, 5, 10, 15, 20, yep, we're adding 5. And the last one, 10, 7, 4, 1, here we're actually subtracting 3 each time. You see? It's that simple, consistent step that's the key.
Now, this consistent pattern has a formal name. It's an arithmetic sequence. And that step size we just saw, that's called the common difference. The crucial point here is that this constant step is the one defining feature we're looking for.
Okay, so now we can spot them. But how can we describe any term in these sequences without having to write them all out? For that, we're going to need the secret formula.
This little equation right here is like a universal recipe.
With this, we can find any term in any arithmetic sequence. Doesn't matter if it's the 5th term or the 5,000th.
So let's break this recipe down. A is just our common difference, that step size we talked about. B is a really clever adjustment for where the sequence starts, and when you put them together, you get the full code.
So what's really interesting here is how it all boils down to 2 critical parts. A tells us how to step, and B tells us exactly where to start from. That's all you need.
Finding one term is useful, for sure. But what about our opening question? We need to add all the terms together. So let's see how this builds. I mean, manually adding 100 numbers is not only slow, it's just asking for a mistake, right? There has to be a more elegant way, some kind of shortcut for finding the total sum.
And that secret has been hiding in plain sight, in mathematics, for centuries. Now this quote sounds a little dense, I know, but the idea behind it is pure genius.
Check out this magic trick. If you pair the first and last numbers, 1 and 10, you get 11. Now the second and second to last, 2 and 9, also 11. Third and third to last, 3 and 8, still 11. Every single pair adds up to the exact same value. It's just a bunch of pairs of 11.
And this illustrates the formula brilliantly. You just figure out the sum of one pair, that's your first term plus your last term, and you multiply it by how many pairs you have, which is just n divided by 2. So that first shortcut is fantastic if you know the last term. But what if you only have the rule? Well, algebra gives us another tool for our kit.
This formula lets us calculate the sum directly from our original secret code components, A and B. We don't even need to know what the last term is at all.
So now we've got 2 powerful tools. Which one do you use? It just depends on what information you have. If you know the first and last terms, use the first formula. If you only know the rule itself, use the second one.
And what's really interesting is that the formula for the sum itself has its own algebraic pattern. The most important piece to see here is P. P is always just half of the original sequence's common difference, A.
Okay, finally, let's look at some pre-built tools for the most common patterns you're going to see out in the world.
Mathematicians have already worked out the sums for these really common sets of numbers. And what's so cool about this is just how simple and elegant these shortcuts are. The sum of the first n odd numbers is just n squared. How great is that?
Pay special attention to this last one. It is so useful. It lets you find the sum of multiples of any number k, like 3 or 7 or 10, just by multiplying the sum of the natural numbers by k.
So the crucial point is this. We've gone from just looking at a simple list of numbers to understanding the powerful algebraic code that governs them completely.
And that's our explainer on arithmetic sequences. The next time you see a repeating pattern, you'll know the code to crack it. Thanks for watching.